Hello and welcome again to the Ways of Math. I'm your host, Dan the Math Man, and today we're going to continue our series on the introduction to sets. This is part 8 of our series. If you missed the previous parts, please be sure to check them out. And always, if you enjoy these videos, please subscribe so you can be notified of future video postings. In today's video, we're going to discuss De Morgan's laws. These are a very important set of laws in both logic and in particular set theory that relate to how certain operations can be transformed. So certain set operations can be transformed. Okay, so we're going to, in this video, state De Morgan's laws, and we're also going to illustrate De Morgan's laws using Venn diagrams. So again, Venn diagrams, remember, are a very useful and powerful tool for helping us to illustrate or visualize set operations and the relations in sets. Okay, so let's begin. So De Morgan's laws, as I said earlier, are very important in set theory and logic. They are a pair of theorems that allow us to transform statements relating to the complements of unions and intersections. Right, so we have this theorem of De Morgan's laws. There's two parts to the theorem. So let A and B be sets, then the complement of A union B is equal to the complement of A intersecting the complement of B. And the second part is, suppose we have the complement of the intersection A and B, so the complement of the intersection of A and B, and that's equal to the union of A complement and B complement, right? So this is A complement or B complement, right? So the basic idea here is if we're not in A or B, then that means we're not in A and we're not in B. And in part 2, we're saying if we're in the complement, so if we're not in the intersection of A and B, then we're in the complement of A or we're in the complement of B. Okay, so here we're going to illustrate De Morgan's law part 1. So we want to show that the complement of A union B is in fact equal to the complement of A intersect the complement of B. So first we start with the left-hand side. So we want to figure out what region is this left-hand side here. So if we consider, here's our standard two-set Venn diagram. So A union B is going to be the regions 1, 2, 3, as we see highlighted in multiple colors here. And if we take the complement of that, so that's the complement of the regions highlighted. So we've highlighted 1, 2, and 3. So the complement will be region 4 and only 4 there. Okay, so that's the left-hand side. Now we're going to build the right-hand side. So consider the complement of A. So that's everything outside of the set A, which includes region 3 and region 4 here, shaded in pink. And then let's consider the complement of B as well. So that's everything outside of B. So that's the regions 1 and 4 here shaded in blue. Now if we intersect these two regions, right, we're asking to intersect the complements. So the complement of A is regions 3 and 4. The complement of B is 1 and 4. So what do they have in common, because we're dealing with the intersection, is in fact just region 4. We see here illustrated in purple the right-hand side of that equation. So the complement of A intersect the complement of B. And in fact, we have the same exact area shaded as we did when we constructed the left-hand side. Okay? So again, the power of Venn diagrams to help us visualize the Morgan's law is very, very useful. Now we're going to illustrate part 2 of De Morgan's law. So again, we're going to construct it in a very similar fashion. We're going to start with the left-hand side of this equation, right? And so this is got the set inside the intersection of A and B, so we start with that. And we see the intersection of A and B, remember, is this region 2 here. And we want to take the complement of that. So the complement of region 2 is going to be all the other regions. In fact, region 1, 3, and 4. So everything outside of region 2 is the complement of this intersection. Now again, we're going to build this right-hand side now. So we start again with the complement of A, here in pink, which are the regions 3 and 4. the complement of B here in blue, which are regions 1 and 4, and the union of these. This time we're taking the union of the complement of A and the complement of B. So we have regions 3, 4, 1, 4. So in union, it's going to be 1, 3, and 4, which we see here illustrated in purple. So regions 1, 3, and 4 are shaded here. Remember, this came from the construction of the right side of the De Morgan's law equation. And we see that that's in fact the same thing that we constructed up here when we constructed the left-hand side of this De Morgan's law equation in part 2. Okay, that was it. Thank you for watching. Please be sure to subscribe, and please leave any comments or suggestions in the comment box below. Again, I hope you enjoyed it, and have a wonderful math-filled day.